A warm welcome to all. I'm gonna tell about symmetry in nature. Universe doesn't allow perfection. At the same time, nature loves symmetry. Symmetrical crystals, snowflakes, flowers, which are nearly symmetrical and so on. But it's not the object in nature that I want to tell about here. It's rather unsymmetrical physical laws and themselves. The four main types of symmetry are translation, rotation, reflection and glade reflection. Then we see some real-life examples of symmetry. Reflection of trees in clear water. Wings of most butterflies are identical on the left and right sides.
Very glad to see you. Symmetry seems to be absolutely fascinating to the human mankind. If you look at me on a symmetrical right, on a symmetrical left, apparently that at least can be awares from a symmetrical from any other way. Let me move into the topic, symmetry in space and time. The symmetry in space and time has features as space-time, and it is described by symmetry in any other form. Next, symmetry in physics. The major role of symmetry in physics is important in simplifying the solutions to the more problems. General relativity in space. The space-time symmetry is used in the study of giving exact solution for the Einstein's field equation of a general relativity. Internal symmetries and the equation. The space-time symmetries are distinguished from internal symmetry, and the Einstein's equation are getting answers from this type of symmetries. Physical system of symmetry. In physics, symmetry of a physical system is mathematical or physical features of a system is preserved or remains unchanged under some form of transport.
Hello everyone, DE-BROGLIE hypothesis about symmetry. To explain the properties of light like interference refraction, light is dependent on wave nature. Similarly, to explain the properties like Crompton effect and photoelectric effect, light is dependent on particle nature. So DE-BROGLIE proved that light is having the dual nature. It travels like a wave and interacts like a particle. We know that in the nature, both light and the particle are in the form of energy. In universe, energy is in the form of matter and radiation. It is the basic concept of the nature that tells us nature loves symmetry. Symmetry in everywhere. Starfish, for example, and reflection of trees in ocean and so on. So, for example, we take a microscopic system such as solar system. Sun is at the center and planets are revolving around it. And another is the atom in the microscopic system. Nucleus is in the center and electrons are revolving around it. So, this two pictures shows that this is the broader symmetry in the nature.
Let's conclude the topic with small quotes. Don't confuse symmetry with time, because everyone knows symmetry is applied in all states like physics, chemistry, mathematics, biology, etc. But in this video, we see two important topics about symmetries in nature. First one is space-time symmetry. In this symmetry, the space don't change with time. And second one is DE-BROGLIE's wavelength concept. In this concept, he already predicted that the properties of phase don't change with energy, and it is also applied in both particles and nature.
Thank you.